Let's take a look at some other types of equations. First one we've already we talked about the formula already, so let's work it. Okay, so we got x plus 2 equals 4x to the third plus 8x squared. Now it says solve each polynomial equation by factoring and using the zero product principle. This is a zero factor property I referred to, just a different name for it. Now the zero factor property says you get 0 on one side, so that's our first step. Now we'd like the x to the largest power to have a positive number before it. So this x to the third, I'm going to leave that over on the right side, and I'll bring this x plus 2 over there also. So I got 4x to the third plus 8x squared minus x minus 2. Remember, when you take anything across your equals, your sign changes. Now at this point, this factoring is a little bit harder than we're working with quadratic equations. This is grouping. 4 more terms. So I'm going to group the first two terms together and the last two terms together. Now looking at the first two terms, they have a 4 and they have an x squared in common, so I'll factor that out. And that gives us x plus 8. Oops, sorry, x plus 2. Try it again. Then our second group has a negative 1 common. Remember, if your first term is negative, you always factor out a negative. And that leaves us x plus 2. Well, now they both have an x plus 2, so I can factor that out. And that gives us 4x squared minus 1. Now the 4x squared minus 1, that's two terms with a minus between them. That's difference of two squares. So the x plus 2 just carries down. And the 4x squared minus 1, 2 times 2 gives you the 4, x times x gives you x squared, and 1 times 1 gives you that. So it becomes 2x plus 1 times 2x minus 1. Well, zero factor property says you get 0 on one side, you factor the other side, you then set each factor equal to 0. So I'm going to set x plus 2 equal to 0, and I'll set 2x plus 1 equal to 0, and 2x minus 1 equal to 0. Now x plus 2, I'll take the 2 over to the right side, becomes a negative 2. That's our first answer. 2x plus 1 equal to 0, I'll take the 1 over, so we get 2x equals negative 1. Then divide both sides by 2. And we get x is equal to negative 1/2. And 2x minus 1 equal to 0. Take the negative 1 to the right side, becomes a positive 1. Divide both sides by 2. And those 2's cancel. And we got x is equal to 1/2. We'll see later on that when you're dealing with a polynomial, your largest power tells you how many answers you're going to have. So the fact we had an x to the third means we're going to have 3 answers. Take a look at one more of those. We got 5x to the fourth equals 40x. Okay. Zero factor property. You have to get 0 on one side. And again, we want the x to the largest power to have a positive number before it. So I'm going to take the 40x over to the left side. So we get 5x to the fourth minus 40x equals 0. Now these have a GCF in common, 5x. And that gives me x to the third minus 8 equal to 0. Now what's inside the parentheses? Two terms with a minus in it. I think difference 2 squares, but nothing times itself gives you 8. So I go on to the difference 2 cubes. Well, the 5x just carries down, and then this becomes x minus 2 times x squared plus 2x plus 4 equal to 0. Now, I won't show all the steps anymore on factoring, but we'll always write down what method I'm using. Now, x squared plus 2x plus 4, I can't factor it down anymore, so I'm ready to start setting things equal to 0. So I'll set 5x equals 0, x minus 2 is equal to 0, and x squared plus 2x plus 4 equal to 0. Well, 5x is equal to 0. I divide both sides by 5. There it goes. Those 5's cancel. And we get x is equal to 0. Now x minus 2 is equal to 0. Take the negative 2 to the right side, becomes a positive 2. Like that. Now x squared plus 2x plus 4, since it won't factor, we're going to use quadratic formula. Now a is what's before x squared, which is 1. B is what's before x, which is 2. And c is our number at the end, which is 4. And our quadratic formula says x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Well, now plug in my numbers. So I got negative b plus or minus b squared minus 4 times a times c all over 2a. Well, that gives us negative 2 plus or minus 2 squared is 4 minus 4 times 1 is 4 times 4 is 16. So 4 minus 16 over 2 times 1, 2. Which gives us negative 2 plus or minus 4 minus 16 gives us negative 12 over 2. Always simplify your radical before you go on in the problem. So in this particular one here, negative 12 is negative 1 times 2 times 2 times 3 all over 2. Now the pair of 2's is going to come out as a single 2, and the negative 1 will come out as an I. So we get negative 2 plus or minus 2i square root of 3 over 2. And since we have an I involved, we want to split it apart. The real part, negative 2 over 2, plus or minus the imaginary part, 2 square root of 3 over 2i. Now these 2's cancel, and we got x is equal to negative 1 plus or minus, those 2's cancel, and square root of 3i. And those are our other two answers. Now our largest power in this problem was x to the fourth. It means we're going to have 4 answers. Doesn't mean they're all going to be real. We had two real ones, and then we had 2 imaginary ones. So anyway, those are our 4 answers. The next equations we're going to look at are radical equations. And let me go ahead and write the steps down here. Step 1. Get a radical by itself. And I'll put in parentheses, don't create a fraction. So you do every step you can up to getting it by itself, with the goal of getting it by itself, but don't create a fraction. Step 2. Raise both sides to a power equal to the index. So raise both sides to a power equal to the index. Step 3, if more radicals, go back to step 1. Step 4, solve for x. Now that's as vague as can be. I mean, that's what we were doing originally, was solving for x. But at this point, this could be a linear equation or it could be a quadratic equation. So you may just have to solve, like I say, a linear equation or the quadratic. You may have to factor it. You may have to use a quadratic formula or whatever other technique you want to. Now step 5. Check your answers. This process will give you the correct answer, but sometimes it'll give you false answers too. So you have to check them. And I probably don't have room to work the problem here, so let me save this. And let me see what this is called. Other types of equations. Okay, so CA, other types of equations. Page 01. Now we're going to follow those 5 steps, so keep those in mind. Okay, so we got x minus the square root of negative 2x plus 7 equals 2. Now our first step said to get a radical by itself. So I'm going to take this this radical here to the right side, and I'll take the 2 to the left side. The reason why is it'll get rid of the negative before the radical. So this becomes x minus 2 is equal to the square root of negative 2x plus 7. Remember, when you take anything across equals, no matter what it is, the sign changes. Now step 2. We got it. Well, that one, we got the radical by itself. Step 2, raise both sides to a power equal to your index. Well, this is a square root, so we're going to square both sides. So I'll take x minus 2 squared and the square root of negative 2x plus 7 squared. Now x minus 2 squared, we have to write out as x minus 2 times x minus 2. The reason why is because that minus in there. You can't just square the x and square the 2. You have to FOIL it like that. Over here, when your index matches the power you're raising it to, they cancel each other out. So that gives us negative 2x plus 7. On the left side, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 gives you a positive 4. Combine together like terms at any step. X squared, negative 2x is negative 4x, plus 4 equals negative 2x plus 7. Well, step 3. If more radicals, go back to step number 1. We don't have any more radicals. Step 4, solve for x. Well, this is a quadratic, which means we want to get everything over one side and 0 on the other. And we'd like the x squared to have a positive number before it. So I'm going to take the negative 2x plus 7 over to the left side. So we got x squared minus 4x plus 2x plus 4 minus 7. When you take anything across equals, the sign changes. At any step, combine together like terms. Negative 4x plus 2x gives us negative 2x. 4 minus 7 gives us negative 3. Okay. This was, I guess, where we started here. This was, try it again. This is step 4, solve for x. Well, this factors. This is the PSD method. X squared x, no x, and there's no number in front of our x squared. So it factors as x minus 3 times x plus 1 equals 0. Well, 0 factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 3 equal to 0. And x plus 1 equal to 0. And we get x equals 3, and x equals negative 1. Well, step 5, check your answers. If I put 3 back up here, the 3 would be there, minus. Negative 2 times 3 would be negative 6, plus 7 is 1. Square root of 1 is 1. So we have 3 minus 1, and that does give us 2. For the negative 1, I'd have negative 1 here, minus. If I put negative 1 in here, negative 2 times negative 1 is a positive 2, plus 7 is 9. Square root of 9 is 3. So we got negative 1 minus 3. That does not give us 2. So that one crosses off. So our only answer is the 3. Let's take a look at another one of those. We got square root of 3x plus 6 minus square root of x minus 1 equals 3. And grab a drink. Okay, first step, get a radical by itself. Now it doesn't matter which one we get by itself. I'm going to take this negative square root over to the right side so it becomes positive. So we got square root of 3x plus 6 equals 3 plus square root of x minus 1. So we got a radical by itself. Well, step 2, raise both sides to a power equal to the index. This is the square root, so the index is 2, so we'll square both sides. So square root of 3x plus 6 to the second power equals 3 plus square root of x minus 1 to the second power. Now over on the left side, when the index matches the power, they cancel each other out. So we got 3x plus 6. I can't do the same thing on the right side because not everything's multiplication inside the parentheses. It's actually a plus there, 3 plus. So we have to write this as 3 plus square root of x minus 1 times 3 plus the square root of x minus 1. Well, 3 times 3 is 9. 3 times square root of x minus 1 is 3 square root of x minus 1. Square root of x minus 1 times 3 is 3 square root of x minus 1. And square root of x minus 1 times square root of x minus 1 gives us x minus 1. Now, no matter where you are, combine together anything that's alike. Over on the right side, the x I'll put in the front. We got 9 minus 1. That's going to give us 8. And we got 3 square root of x minus 1 and 3 square root of x minus 1. If the radicals are the same, then you add the numbers in front of them. So that gives us 6 square root of x minus 1. Okay, we're ready for step 3. Step 3 says if more radicals, go back to step number 1. And so we're back to number 1. Step number 1 says get a radical by itself. So I'm going to take the x plus 8 and move them to the left side. So we get 3x minus x plus 6 minus 8 equals 6 square root of x minus 1. Combine together like terms, 3x minus x is 2x, 6 minus 8 is negative 2. Now the radical is not quite by itself, but if I divide both sides by 6, I'm going to create a fraction. And we said we don't want a fraction. But I can make it a little bit simpler. I can divide everything by 2. So I divide that by 2, this by 2, and the right side by 2. So that's going to give us x minus 1 is equal to 3 square root of x minus 1. Okay, that's as close as we're going to get getting it by itself. So then step 2. Raise both sides to a power equal to the index. This is square root, so we'll square both sides. So we got x minus 1 squared is equal to 3 square root of x minus 1 squared. Now x minus 1 squared we have to write as x minus 1 times x minus 1. Because of the minus in there, we can't just square the x and square the 1. Now over on the right side, everything inside the parentheses is multiplication. So we can take the 3 to the second power, and we can take the square root of x minus 1 to the second power. So we're going to have 3 squared and square root of x minus 1 to the second power. Well, over on the left side, x times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. And I forgot an x there, so let me do that over. Negative 1x. And negative 1 times negative 1 is a positive 1. Now 3 squared is 9. And when I square this square root, they cancel each other out and leave me x minus 1. So I got x squared minus 2x plus 1 equals 9x minus 9. Well, we're down to step 3. Step 3 says if more radicals, go back to step number 1. I don't have any more radicals. Well, step 4, solve for x. Well, this is a quadratic, so I want to get everything over on one side. So I'll take 9x minus 9, move them over to the left side. So I get x squared minus 2x minus 9x plus 1 plus 9. Remember, when you move anything across equals, the sign changes. Combine together like terms. I got x squared minus 11x plus 10 equal to 0. Zero factor property. This is the PSD method. X squared x, no number in front of the x squared. This factors as x minus 1 times x minus 10 equals 0. Zero factor property. You get 0 on one side, you factor the other side, set each factor equal to 0. So set x minus 1 equal to 0, and x minus 10 equals 0. And then we solve those, and we get x equals 1, and we get x equals 10. Well, let's go up and check those. 1. If I put 1 in here, 3 times 1 is 3, plus 6 is 9, square root of 9 is 3. If I put 1 in here, 1 minus 1 is 0, square root of 0 is 0, 3 minus 0 does give you 0. So that one checks. Let's check the x equals 10. If I put 10 up here, 3 times 10 is 30, plus 6 is 36, square root of 36 is 6. So this is 6. 10 minus 1 is 9, square root of 9 is 3. 6 minus 3 does give you 3. So that one checks also. Okay. Now we have, and these problems actually used it, a general form that's not so specific. It just says for a power principle, you can raise both sides of an equation to a power. Now the power cannot be equal to 0, because if you take both sides of 0 power, then you get everything disappears. But you can raise both sides of an equation to a power. Now this is a tool used to help solve equations. I'm going to put another note on here. Be sure to check your answers. Very important. You know, here's an example. We got this equation here. And if I ask you to solve it, you'd look at me kind of funny. It's like, what do you mean? This is a pretty simple equation. It's already solved. So our answer is 2. We got one answer, right? Well, imagine if I took both sides of the 200th power. Well, that'd give me x to the 200th equals 2 to the 200th, whatever that gives you. Now, when we're talking polynomials, your largest power of x tells you how many answers you're going to have. Well, this says we're going to have 200 answers now. Well, but only one of them is correct. The other 199 wouldn't be, or they're duplicated, one of the two. So again, you can raise both sides to a power, but be sure to check your answer, because you'll get some extra answers that aren't right. Let me save this, and then we'll take a look at a couple of problems on that. There we go. Okay, let's look at this problem here. And we'll also look at this one here. Well, we just saw the square root, so let's do that one first. Well, remember the square root of x is x to 1/2, but we square both sides basically. Now the reason why we do that is if I put this in fractional power form, and that whatever number's in this little slot here is what goes in your denominator, to get rid of the exponent, you're going to raise both sides to the reciprocal of that, which would be 2/1. Like that. Now when I do that, those 2's going to cancel. And we get x is equal to 5 squared, which is 25. So that's our answer. Now this one, x squared, I can rewrite as x to the 2/1 power equals 9. And we want to raise both sides to a reciprocal of that. So we got 2/1, the reciprocal will be 1/2. And those 2's would cancel. And we got x is equal to, and 9 to the 1/2 is square root of 9, which is the same as 3. But we saw this in the quadratic equations where you have something squared equal to the other side, you drop a square, and you put a plus or minus square root on the other side. So we would actually need a plus or minus here, and plus or minus here. Well, why did we put a plus or minus here and we didn't put a plus or minus on this one? Well, if we once it's in fractional power form, rational exponent, if the numbers on top is odd, if odd, then no plus or minus. Now, if we have it in fractional power form and the number on top is even, so if even, then that's when you put a plus or minus on it. So that's going to be our guideline when working these next set of problems. Okay, so we got x minus 4 to the 2/3 power equals 9. Now, in order to get rid of the exponent, the part that's to a power has to be by itself. And this is good because it is by itself. So now we're going to raise both sides to a power equal to the reciprocal of that. Well, the reciprocal of that would be 3/2. Okay, the question becomes whether to put a plus or minus on it. Remember, if we have it in fractional power form, if number on top's even, then you put the plus or minus. So the number on top here is even. So we need to put a plus or minus. So put a plus or minus right here. Now over on the left side, 2's cancel, 3's cancel. And we're left with x minus 4 equals plus or minus. And when we got a number to a fractional power, we can split that up. We'll take the number that's on top, the 3, and put it on the outside of the parentheses. And then we have 9 to the 1/2 inside. Reason why we do that is 9 to the 1/2 is the square root of 9. So then, square root of 9 gives you 3, so we have 3 to the 3rd. And 3 to the 3rd gives you 27. Now we're going to solve for x. I'm taking the 4 over. And we get 4 plus or minus 27. Now here it's beneficial for us to split it into two separate pieces. So we're going to have x is equal to 4 plus 27, and x is equal to 4 minus 27. So x is going to equal 31, and x is going to equal to negative 23. Well, if I check my answers, we put 31 back up here. That gives us 27. That would give us 3 squared, 9, so that checks. If I put negative 23 up here, that gives us negative 27, and then that gives us 9, so that checks. So both of those check. Remember, when you raise both sides to a power, that's when you have to check your answers. Let's look at another one. So we got x squared minus 5x plus 10 to the 3/2 power minus 8 equals 0. That says solve each equation with rational exponents. A power principle is what we're going to be doing. We have to get the part that's to a power by itself. So I'm going to take that negative 8 over to the right side. So we get x squared minus 5x plus 10 to the 3/2 power is equal to 8. Well, I'm going to raise both sides to a power equal to the reciprocal of that. So I got x squared minus 5x plus 10 to the 3/2 power. Raise both sides to the 2/3 power. Now, this is in fractional power form. The number on top is odd, so no plus or minus. Now over on the left side, the 3's cancel, the 2's will cancel, and we're left with x squared minus 5x plus 10. And over on the right side, I can split that up. I can put the numerator on the outside of the parentheses, so we got 8 to the 1/3. So we got x squared minus 5x plus 10. 8 to the 1/3 is the cube root of 8. Well, the cube root of 8. 2 times 2 times 2. Now our index is 3, so we're looking for a set of 3 of something. So that 3 2's is going to come out as a single 2. So I got x squared minus 5x plus 10 equals 2, and then the second power is still on the outside. So I got x squared minus 5x plus 10 equals to 2 squared is 4. Now I'm going to take the 4 over to the left side. So we got x squared minus 5x plus 10 minus 4 equals 0, which gives us x squared minus 5x plus 6 equal to 0. And as factors, using the PSD method, x squared x, no number in front of our x squared. So this would be x minus 6, okay, I'm lying to you. Just kidding. X minus 2 times x minus 3 equals 0. Set each factor equal to 0. X minus 2 equal to 0, and x minus 3 equal to 0. And we get x equals 2, and we get x equals 3. Maybe. And if I come back up here and check those, put 2 in here. 2 squared is 4 minus 5 times 2, that's negative 10. Negative 10 plus 10 cancels, so that gives us 4 to that, which gives us 8. 8 minus 8 is 0, so that one checks. 3. Well, if I put 3 up here. 3 squared is 9. That's negative 15 plus 10, that's negative 5. 9 minus 5 is 4. 2, 8, yeah, that checks 2. So both of those are our answers. And let me save that. And let's look at our next problem. This should be a U-substitution. Yep. And let me rearrange my seating here a little bit. Oh. So we got x to the 4th minus 5x squared plus 4 equal to 0. And we want to solve this using the U-substitution. Now step 1. Let the variable part of the middle be u, and the variable part of the first be u squared. So this right here is u, and this right here is u squared. So we're going to have u squared minus 5u plus 4 equal to 0. Now you notice after we've done the u substitution, it's now a quadratic, which we got a lot of techniques for that now. Now, when can you use the u substitution? If you can take the variable part of the middle, which in this case was x squared. If you can take it to the second power, and it gives you the variable part of the first. That's what tells you can use it, which it does in this case. Now step 2. Solve for u, in whatever manner you see fit. This factors. So I'm going to use the PSD method. This factors as u minus 1 times u minus 4 equal to 0. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set u minus 1 equal to 0, and u minus 4 is equal to 0. And we get u is equal to 1, and u is equal to 4. Step 3. Plug u equals blank back in and solve for x. Every problem will be different in this step. In this particular one, we let u equal to x squared up here top. So now we're going to plug x squared back in for the u. So we got x squared is equal to 1, and x squared is equal to 4. Again, it's kind of vague on how to solve for x because there'll be all different kinds of techniques at this point. This is the square root property. We'll drop off our squared, and you put a plus or minus square root around the other side. So drop our squared, put a plus or minus square root on the other side. Now, square root of 1 is 1, so we got x is equal to plus or minus 1, and this will be plus or minus 2. And those will be our answers. Now notice here we use the square root property, but that's already been verified. That will give you the correct answer every time, so you don't need to check that. But normally if you raise both sides to a power, you have to check your answers. Okay, let's look at this one. So we got x to the 2/3 plus 6x to the 1/3 minus 7 equal to 0. Step 1. Let the variable part of the middle be u. So this will be u, and the variable part of the first be u squared. So this becomes u squared plus 6u minus 7 equal to 0. Now again, if you can take the variable part of your middle, which is x to 1/3, raise it to the second power, and it gives you the variable part of the first, that's when you can use this. Now step 2, solve for u. This is the PSD method. U squared u, no u, and there's no number in front of u squared. So this gives us u plus 7 times u minus 1 equals 0. Set each one of those equal to 0. So set u plus 7 equal to 0 and u minus 1 equal to 0. And you get u is equal to negative 7 and u is equal to positive 1. Step 3. Let u equals blank, or plug u equals blank back in and solve for x. Up here we said u is equal to x to 1/3. So we'll put x to 1/3 in for our u now. Now I'm going to raise both sides to a power equal to the reciprocal of that. So this will be x to the 1/3, and I'll raise it to the 3/1 power. And I'll raise this to the 3/1 power. This one I'll raise to the 3/1 power, and I'll raise the 1 to the 3/1 power. Now here the 3's cancel, and here the 3's will cancel. So we got x is equal to negative 343, and on this one, 1 to any power is 1. 49. Put that in there. Positive 49. That one checks. Put that one in there. 7 minus 7. That one checks. So both those are answers. Again, whenever you raise both sides to a power, you have to check your answers. Now remember, since this was in fractional power form, rational exponent, and this was an odd number, that means that's why we didn't put the plus or minus. Let's look at one more of those. Let me get a drink also. Okay, so we got x squared minus 2x to the second power minus 23 times x squared minus 2x plus 120 equal to 0. And we'll do the U-substitution. We let u equal the variable part of the middle. So this will be u, and the variable part of the first be u squared. So that gives us u squared minus 23u plus 120 equal to 0. And I'm I'm not sure if I see this one. I think I see it. So this factors as u minus 8 times u minus 15 using the PSD method. Let me see if that's 0, 4, 8. Okay. Yeah, that's right. Okay. So now set each one of those equal to 0. Set to u minus 8 equal to 0 and to u minus 15 equal to 0. And we get u is equal to 8 and u is equal to 15. Now remember step 3. Plug our u equals back in. U we said was x squared minus 2x. So put in x squared minus 2x for the u, and I get x squared minus 2x equals 8, and x squared minus 2x equals 15. Now I want to get everything over one side and factor it if I can. So I'll take the 8 and the 15 to the left side. So I got x squared minus 2x minus 8 equal to 0, and x squared minus 2x minus 15 equal to 0. And both of those are the PSD method. So this one factors as x minus 4 times x plus 2 equal to 0. This one factors as x minus 5 times x plus 3 equal to 0. Now set each one of these equal to 0. So x minus 4 equal to 0, x plus 2 is equal to 0, x minus 5 is equal to 0, and x plus 3 is equal to 0. So here take negative 4 over, becomes a positive 4. Here take 2 over, becomes a negative 2. Here take negative 5 over, becomes a positive 5. And here take 3 over, and it becomes a negative 3. Now we didn't raise both sides to a power, so I don't have to worry about checking my answers. And let me save that. And next one, I think, is an absolute value equation. Yes, it is. So let's talk about how to solve those. We got a formula. This says if you have the absolute value of something is equal to something else, then you drop the absolute value, set it equal to positive the other side, drop the absolute value and set it equal to negative the other side. Absolute value has to be by itself for you to use this formula. So let's look at this one. So we've got 5 times the absolute value of 4x plus 3 equals 20. Well, the absolute value is not by itself, so we'll divide both sides by 5. Like this. And do that, those 5's going to cancel. And we got the absolute value of 4x plus 3 is equal to 4. Okay, so we got it in our form we need. So our formula says if you got the absolute value by itself equal to the other side, you drop the absolute value, set it equal to positive the other side. So we got 4x plus 3 is equal to 4. And you drop the absolute value and you set it equal to negative the other side. So we have 4x plus 3 is equal to negative 4. Now we're going to solve for x. So I take 3 over, and I'll take 3 over here. So I get 4x is equal to 4 minus 3. And here I get 4x is equal to negative 4 minus 3. Well, on the left side there, I got 4 minus 3, which is 1. And on this one, we got negative 4, negative 3, which gives me negative 7. Divide both sides by 4. And we end up with x is equal to 1/4. Those 4's canceled. Over here, divide both sides by 4. And those 4's cancel. And we got x is equal to negative 7/4. So those would be our answers. And let me grab a drink here. And let's look at our next problem. Got the absolute value of x minus 3 plus 8 is equal to 1. Well, to use our formula, the absolute value has to be by itself. So I'm going to take the 8 over to the right side. So we've got the absolute value of x minus 3 is equal to 1 minus 8. Well, 1 minus 8 is negative 7. Now this is the oddball case you got to watch out for. If you got the absolute value by itself and you got it equal to a negative number, remember what the purpose of absolute value is. It makes whatever's inside positive, or it can be 0. So when you're asking when is an absolute value equal to a negative number, it's never. So the answer here is no solution. Do not apply the formula. You apply the formula, you get a couple of answers, but they aren't right. Now this one's another oddball case. We got 5x plus 1 inside the absolute value plus 6 is equal to 6. Well, again, we have to get the absolute value by itself. So I'm going to take the 6 over to the right side. So we got the absolute value of 5x plus 1 is equal to 6 minus 6. Or the absolute value of 5x plus 1 is equal to 0. Now this particular oddball case, if you don't spot it, it's not such a big deal. It'll become apparent. But remember, our formula says drop the absolute value, set it equal to positive the other side. Drop the absolute value and set it equal to negative the other side. But positive 0, negative 0 is just 0. So this particular problem just becomes 5x plus 1 is equal to 0. And then we solve it. So take the 1 over. You get 5x equals negative 1. Divide both sides by 5. And those 5's cancel. And we get x is equal to negative 1/5. And that's our answer. And let's look at our last problem. This is again an oddball case. So we've got the absolute value of 4x plus 1 is equal to the absolute value of x minus 2. Now this oddball case is we got an absolute value equal to an absolute value. To work this one, pretend it looks like this right here. The absolute value of 4x plus 1 is equal to x minus 2. Drop one of your absolute value bars. It doesn't matter which one. And it'll give you the right answers. Now, you could use that formula up above, but you'll have an extra 5 or 6 steps on this. And normally I don't show shortcuts, but this happens so seldom that it really is useful to use it. Okay, the absolute value is by itself, so we're going to drop the absolute value bar, and we're going to set it equal to positive the other side, and we'll drop the absolute value bars and set it equal to negative the other side. Now notice when I set it equal to negative the other side, I put parentheses around it, because that negative has to change the sign of everything. Well, on my first equation here, I'm going to take the x over the left side, take the 1 over to the right. So we've got 4x minus x is equal to negative 2 minus 1. 4x minus x gives us 3x. Negative 2, negative 1 is negative 3. Divide both sides by 3. And we get x equals negative 1. Those 3's cancel. On this one, the negative before the parentheses again flips the sign of everything inside the parentheses, so it becomes a negative x plus 2. Get all the x's on one side, numbers on the other side. So I got 4x plus x is equal to 2 minus 1. 4x plus x is 5x. 2 minus 1 is 1. Divide both sides by 5. And we get x is equal to 1/5. Because those 5's cancel. And those are our 2 answers. And let me save this page. And that's actually the end of that section. So let me go ahead and stop the recorder.